I've done this talk before, but I'm going to do it with a slightly different slant. But because the basic material is always the same in terms of what general points you hit. But I thought what's been interesting me lately is how you optimize the delivery of the major substrate of energy production to the brain, and really how to optimize the cell's ability to assimilate that major substrate. And the major substrate is oxygen, and the point of interest from the cellular point of view is the cell membrane. So while I'll be speaking to many different things, what I hope to leave you with is the ideas of, one, how we would determine whether or not, one, enough oxygen was being carried in the arteries to the tissues of the body, and two, whether the tissues were absorbing that oxygen or taking it up adequately, and then three, how could we determine the quality of our cell membrane in terms of the constitution of the essential fats that make it up and are so important, and then how would we treat? Because I think right now those things to me are very sort of basic, constitutive things that aren't hard to do, aren't terribly expensive to do, and which, if applied systematically, I think would produce benefit to people. Next. So, Will Rogers, you know you are getting when everything either dries up or leaks. It's hell. Okay. Next. And can we get from here to there without losing our minds? You know? The whole goal is to get into our into our advanced old age, which I now characterize as 85 and above, with being functionally independent. And I would like to get a little T-shirts that say, no diapers, no walkers, no wheelchairs. My wife thought I would offend people with that. But, in the end, functional independence is the key. Be able to do for yourself and do for others is really the big, big goal. And to the degree we can achieve that, both with whatever high-tech things come along, but also with whatever relatively low-tech things we can do, I think we'll serve ourselves and our society. Next. And the contributors to the decline in brain function include toxic burden. There's just been in the news a statement from the President's Council, some presidential committee initiated by George Bush the Lesser, but nevertheless by him, but recorded during the Obama administration, pointing out that the contribution of toxic materials to cancer incidences has been far underestimated. And of course, American Chemical Society and the American Cancer Society came out and say, oh, no, this is too strong a statement. But having said that, this issue of toxicity from the environment is very germane and really is terribly important, and we discussed this in other talks. Infectious burden, could chronic infections contribute to our problems? Yes. Chronic inflammation? Yes. High blood pressure, perhaps almost the easiest stuff from a conventional medical point of view to help people with. Keeping that systolic blood pressure less than 130 and that diastolic blood pressure less than 85. Boy, that's so important. Controlling blood sugar, measuring and optimizing the ability of the organelles in the cells that produce energy aerobically, that is to say, use oxygen to produce energy, the mitochondria, understanding if they're functioning optimally and correcting it, and then the decline and oxygenation of tissue, which I had alluded to. Next. This is just an elephant's eye that I tried to... Oh no, that's the rhino's eye, I'm sorry. Thanks. That was a test of cognition. We got close, but not that close. Next. That is a good picture. Heavy metal transition, and the heavy metals, there's no evidence of a direct causation between toxic metals and neurodegenerative disease, but there is evidence that a toxic metal body burden may be permissive to brain aging and neurodegenerative diseases, in part because lead, as an example, impairs the health of the lining of the blood vessels, the endothelium, the one-cell thick lining of all the muscular arteries and arterioles, some as small as your hair follicle, some as small as the shaft of your hair, that are the action area of the arteries, where oxygen goes in and carbon dioxide comes out, and where other nutrients go in and waste materials go out. Next. There is evidence that a lead body burden acquired in childhood is associated with an increased risk to Alzheimer's disease in later life. The lead body burden we got in childhood came from the gasoline fumes we inhaled, and we all got it. And we all sequestered the lead in our bone as we were growing. And now as we're getting older and our bone gets thin, the lead comes out. It leaches, and so the levels go up, and etc. And so you can measure this pretty easy, and we can treat it. There's evidence that an imbalance of the copper, zinc, and iron contribute to brain inflammation and brain aging. So that, again, from time to time, I'll measure copper and zinc. It's been a little bit more difficult with the Medicare-age patients because it's not, you need to have a very clear diagnosis, and usually I can get away with it. But the simple point is this: even when copper and zinc are normal, but copper is higher than zinc, all-cause mortality is increased by 30%, cancer mortality, I think, by 40%. And so, on the one hand, I don't want to give people supplements with copper, particularly if they don't need them, and on the other hand, I might suggest supplementation with zinc. And there's good evidence that lead and mercury body burdens can contribute to peripheral neuropathy. Next. Other industrial pollutants, there's reasonable evidence that pesticide exposure is associated with an increase in neurodegenerative disease, and the case for organic solvents is less clear. So